Most students will approach this question using the second method, but this method is quite cumbersome and you need to be very careful using it. Let's say we have our question, square root of x squared plus 3x minus 28 plus square root of x squared minus 2x minus 8 equals square root of 6x squared minus 11x minus 52. Most students will approach this question by squaring both sides, unlike the previously used method. When you square both sides, on the left you apply the formula a plus b squared equals a squared plus b squared plus 2ab, where this is your a and this is your b. So a squared, you get this, the square root goes off. B squared, you get this, the square root goes off, because this is b, the square cancels the square root, you have this, and 2ab, 2 times the value of your a with the square root multiplied by the value of your b equals, on the right, the square will cancel the square root. On the next line, you collect like terms on the left, while on the right, you still leave it as it is. On the left, you add or subtract the like terms, and on the right, you still have the initial value. Next, you take all the algebraic expressions and the constants that are not linked by times to the root, take them to the right. So you can have only root on the left. You take them to the right, the plus 2x squared turns to minus 2x squared, the plus x turns to minus x, the minus 36 turns to plus 36, you have them on the right. Still leaving what you have on the left unchanged. On the right, you collect like terms, and you either add or subtract. 6x squared minus 2x squared will give you 4x squared. Then you have minus 11x minus 1x will give you minus 12x, and minus 52 plus 36 will give you minus 16. Once you have this, on the next line, the weakest link on the left is the 2. You get it off by dividing both sides by 2. Now you introduce over 2 to both sides. On the right, since you want to divide this by this 2, you can either say this 2 in this 4, this 2 in this 12, and this 2 in this 16, because they are linked by subtraction. And if you are linked by subtraction or addition, these 2 will have to go in each of them, or you can factorize and bring out 2 in all of them. If you take 2 out of 4x squared, you'll be left with 2x squared. If you take 2 out of 12x, you'll be left with 6x. And if you take 2 out of 16, you'll be left with 8. The reason why you brought out the 2, so this 2 can cancel this 2. And as shown on this line, the 2 cancels the 2, you'll be left with 2x squared minus 6x minus 8 on the left. This 2 cancels this 2. We've taken 2 off the left. We now have this. Next, we can get rid of on the left is the square root. You square both sides. By the time you square both sides, this square will cancel this square root. You'll be left with the two values multiplying themselves under the square root. X squared plus 3x minus 28 in one bracket, x squared minus 2x minus 8 in the second bracket equals, on the right we work with our quadratic expression which is squared. So repeat it twice, then you expand. Imagine going through this process of expanding. By the time you expand what is on the left, you get a power of 4, and on the right you get a power of 4 too. But on the right, the coefficient of x to the power of 4 is 4, while on the left it's 1. And I don't want the letter with the highest power to be negative, so I take this plus 1 x raised to the power 4 to the right, and I also move every other value on the left to the right. We now have everything on the right, but we choose to put our equals to sign on the right and leave all of this as if it's on the left. It still applies in math. You can put your equals to 0 on the left, or you can put it on the right. There's no positive or negative 0, 0 is 0. That's why you have it like this. Next, you collect like terms. 4x raised to the power 4 minus x raised to the power 4, you have this x raised to the power 4 here with negative. It comes to join this. You do the power of 4s first, then you go to the letters with the power of 3, you group them together. The power of 2, you group them together, and you have to be very careful here not to make any mistake as regards the numeric values or the positive or the negative signs. So you have this all like this, and at this point you add or subtract. Like in this case, you have 4x raised to the power 4 minus 1x raised to the power 4. It gives you 3x raised to the power 4. You have minus 12x raised to the power 3 plus 2x raised to the power 3 minus 3x raised to the power 3. You work on them and you get minus 25x raised to the power 3. Same as you work with the x raised to the power 2, the x to the power of 1, and then the constant. You get this value. This is now a polynomial to the power of 4. Solving for x at this point means you start testing for x. You can start with 1. When x is 1, you try it. If it doesn't work, you go to x is 2. You know x is 2 will work. because from the first method we discovered that one of our values is x is 2. You can do that on your own. When you change this x to 2 and solve this question, you get that your result is 0. Also, when you try 4, you get 0. Before you jump to 4, you have to try 3. In some cases, try 0, -1, and so on, of which when you change the value of x to its numeric value, you get 0. Knowing that x is 2, and in solving a polynomial question, you have to take the 2 and bring it back to the left. So you have it x minus 2 equals 0. Now, once you have x minus 2 equals 0, you use the x minus 2 to divide this polynomial to the power of 4 and get a lower polynomial that can help you get the other values for x. It's going to take a lot of time and it's going to be very stressful.